binomial probability. An event has only two possibilities. And when you think about it, any event can be broken down to two possibilities. Either it happens or it doesn't happen. So, this will cover a lot of different types of questions. And that event is repeated. Probability distribution would go like this. Well, we'd start off and do it once and we could get A or a B. Now, the probability of A happening, we're going to say P. Probability of B happening would be Q. Q, of course, therefore, is 1 minus P, because they've got to add up to be 1. All right, but then we're going to do it again. Now, if I started off with an A, I could then have AA or AB. But if I started off with B, I could have BA or BB. Probability of them happening. P squared, PQ, PQ, and Q squared. Okay, let's branch off again. Now, if I've gone down the AA track, I'll get AAA, then AAB, ABA, ABB, BAA. That's the sheep probability. BAB, BBA, and BBB. Okay. Probability of those happening. P cubed, P squared Q, P squared Q, PQ squared, P squared Q, PQ squared, PQ squared, or P cubed. Oh, what the heck? Let's do it one more time. We can get AA, AB, ABA, AB, ABR, and down to the last one, which takes us back to our childhood. All right, now, the probabilities of those happening. P to the 4, P cubed cubed, PQ cubed, P squared, P cubed Q, P squared, P squared, P squared, P squared, PQ cubed, P cubed Q. Gee, they sound the same when you say them quick, don't they? P cubed Q as opposed to PQ cubed. But they are different if you listen carefully. Right? And we get to the very last one there, Q to the power of 4. Now you may not see it, but there's a familiar pattern there. If we don't care about the order that things happen. Let's have a look. One event, well, that was pretty boring. Probability of A happening was P, probability of Q was happening was Q. But when we had two events, if we don't care about the order, then the probability of an A and a B, there was two ways we could do it. We could A and a B or a B then an A. 2PQ. So the total number is P squared plus 2PQ plus Q squared. That is familiar. Three events. Again, we see something familiar. Two A's and a B, but we don't care the order. 3P squared Q. A and a 2B, 3PQ squared. QQ. Ooh. Four events. P4, 4P cubed Q, 6P squared Q squared, 4PQ cubed, and Q to the power of 4. Look at those coefficients. They're very, very familiar. And it's not a coincidence. Because all we're really doing is expanding out P plus Q to the power of something. Because all the probabilities are P and Q. They add up to be 1. So if I wanted to work out all of the probabilities, if there were 4 events, I'd be saying, well, first event, P plus Q. Probability of 1, it must happen. Times P plus Q. Probability of 1, it must happen. Times P plus Q. Probability of 1, it must happen. Times P plus Q. Probability of 1, it must happen. P plus Q to the power of 4, which of course we know the expansion is that. So there's a very direct link between our binomial theorem and the probability. So what that means, if we're going to repeat something n times, and the probability of x is P, probability of x not happening is Q, then the probability that x will occur exactly k times, so we don't care the order, but it'll happen exactly k times, will be the general term of our binomial theorem. And so we just have to substitute into the general term, and P and Q will be those probabilities. Now, the notation I use there, probability x equals k, so that basically means that x, whatever that event is, will occur exactly k times. So if, say it was 3 events, and we wanted B to happen twice, then we would go 3C2, which is 3. P would be the power of 1. q would be the power of 2. Now, this is the difference. You remember with permutations and combinations, it was without replacement. And if we did use replacement, then we just went back to the basic counting idea. Binomial probability is with replacement because the probability has to be the same every single time. So a bag contains 30 black balls and 20 white balls. 7 drawings are made with replacement. Probability of drawing all black. Okay. So probability that x being the probability of pulling out a black ball, is 7, would be 7c7, probability of it happening to the power of 7, probability of it not happening to the power of 0. Now, you might have logically done this question anyway and said, oh, well, probability of black is 3/5, so I'm going to get 7, or 3/5 to the power of 7. But you can see it's the same answer. So 7c7, 3 to the power of 7, 5 over 5 to the power of 7, 7c7 is, of course, 1. There we are. 2,187 on 78,125. But if we say, okay, look, we're only going to pull out 4. Don't care the order. I'm just going to pull out 4. So I'm now saying, well, what's the probability that x, that event, happens 4 times? 7c4, the probability of it happening to the power of 4, therefore, probability of it not happening, power of 3. 7c4, 2 cubed, 3 to the power of 4, over 5 to the power of 7. And there's our answer. A lot of these ones, certainly once those numbers start getting big, we just leave them in unsimplified form. All right, election. Oh, kind of topical. In an election, 30% of voters favoured party A. If at random an interviewer selects 5 voters, what's the probability that 3 of them favoured party A? So we're saying the probability that they favour A, 30% or 3/10. So I'm going to let X be the number of people favouring party A. Probability that 3A, or well, I suppose I should have put X equals 3, but anyway. 5C3, probability of it happening to the power of 3. Probability of it not happening to the power of 2. There it is in its unsimplified form. 1323 over 10,000. Majority favoured A. I've got to go back to our probability. Majority greater than or equal to 3. Because I'd need 3 or 4 or 5 of them. I suppose I could have done 1 minus minority, but either way I'm going to have to work out 3 probabilities, because minority would have been 0, 1 or 2. So it doesn't really matter. So there it is, each particular term, probability of it happening to the power of the number, so 3, then 4, then 5. Probability of it not happening, the 2 powers have got to add up to be 5. But don't forget the binomial coefficient. That's quite possibly one of the more common mistakes that's made with this sort of question, and people forget to put the binomial coefficient out the front. There it is in its unsimplified form, 5c3, 7 squared, 3 cubed, etc., etc. That works out to be, there we go, 4,077 on 25,000. At most, 2 favoured A. At most 2 favoured A. Okay, don't get tricked with the language that they use. Think about it carefully. What does that mean? At most 2 favoured A, that's 1 minus what we just worked out. Because we just worked out 3, 4 or 5. So if at most 2, 0, 1, it's just going to be 1 minus what we just worked out. So I'm going to do it that way. And so I'll just subtract our answer we just found. Let's look at an HSC one. Okay, 5 matches on a weekend of a football season. Megan's taking part in a competition. 1 point if she picks more than half of the winning teams for a weekend. 0 points otherwise. Well, that's a tough little tipping comp. Okay. The probability that Megan picks correctly, she's found to be 2/3. She usually gets 2 out of 3 correct. So show the probability that Megan earns 1 point. She earns that point in a given weekend, and they've rounded off to 4 decimal places. Okay. So X is going to be the number of matches that she picks correctly. We want the probability that X is greater than or equal to 3, because she'll get 1 point if she picks more than half. There are 5 games, so 3, 4, or 5. So 5C3, probability of it happening 2/3 to the power of 3, not happening to the power of 2, and then 4 right, and then 5 right. There it is, unsimplified, but they wanted the 4 decimal places, so a bit of calculator work. And, oh, there you go, 0.7901. Okay, next part of the question. Let's go and find the probability that Megan earns 1 point every week of the 18-week season. Every week. So I'm now going to change what I'm investigating, because I now want to know that y is now going to be the number of weeks that she earns a point. Okay. So I'm saying y is going to equal 18. But the probability that she earns a point, we just worked out. It's 0.7901. So it'll be 18C18, probability that she earns a point to the power of 18, doesn't earn a point to the power of 0. And we get 0.01 to 2 decimal places. All right, final part of the question. I think this is the final part of the question anyway. Find the probability that Megan earns at most 16 points during the 18-week season. 16 points out of an 18-week season. She's either going to get 1 point each week or 0 points each week. So what we're basically saying is that y has to be less than or equal to 16. Well, in this case, I don't want to work out 0, 1, 2, 3, 4, 5. And so it is going to be easy to go 1 minus 17 points and 18 points, certainly given that we've already worked out what 18 points is. So 17 points, 18C17, 0.7901 to the power of 17, 0.2099 will be to the power of 1, and also minus the one we just worked out, and we get 0.92 to 2 decimal places. 2007 HSC. In a large city, it is known that 10% of the population has green eyes. Green eyes. Anyone here got green eyes? Yeah. What is the probability that 2 randomly chosen people have green eyes in this large city? Okay. Oh, this isn't binomial probability. This is just basic probability. We're just picking 2 people. We want to know what's the probability they have green eyes. Well, we know there's a 10% chance that each person has green eyes. So probability of green, 0.1 times 0.1. This is where the binomial probability came in. What's the probability that exactly 2 of a group of 20 randomly chosen people have green eyes? So X is going to be the number of people with green eyes. I want exactly 2 out of 20. So now it is the binomial probability. 20C2, probability of it happening to the power of 2, probability of it not happening to the power of 18, and to 3 decimal places for this one. So 0.285. Probability more than 2 of a group 20 have green eyes. So greater than 2 would be 1 minus probability that we just worked out. So 1 minus the less than or equal to 2. Oh, actually, it wasn't what we just worked out, because we only worked out equal to 2. We also now have to subtract 1 and 0. That one works out to be 0.32. 0.32. All right, so now we can jump back to exercise 10J. Complete that missing exercise at the end of perms and coms. We'll do the evens.